an idea of solving in the class. I didn't complete this question, so let me do it in the revision now. Only 2% switched on the camera, about 11 are here. What about 2 more students? What happened to them? 13 in the class. Let me check in the file. Yeah, you are 13 in the class. Or maybe bot. I didn't check the list yet. All are here. Supposed to join. All settled, I think. What pending? I will wait for another 15 minutes only for attendance. Please tell your friends to join. Only 11 in the class for revision. It's not fair to do like this. Cannot excuse many times. Okay, let's start working out the answer. Let me go to the mode. All of you switch on your camera. Only 3 of you are switched on. What about the others? Okay, have you drawn the given data and then free body diagram? We move on to solve. If you have done that part, get trying yourself to read until I start. We have a test next week. Okay, let's understand the question given to you. Can you see the word file?
Yes.
Okay. So you are given with the member connected by two parallel members AD and EG. AD and EG. See here, there are two members AD and EG given to you. They are connected by two links. They are interconnected by two links to be in a position and like this. And is being loaded by 24 kilonewton at this point at G. You are asked to calculate how much is the factor of safety to be determined. Okay, how much is the factor of safety should be determined or followed to have this much loading, these types of links and these types of members, and the pins. See here, pins at A, pins at B, pins at E. It is connected by pins. This is not fixed, all are pin join. That is important for you to remember. It's a pin join. There is no fixity, so it is free to move. You have to take into account accordingly when you calculate your moments and others. Okay. In this case, how are you going to solve for the factor of safety? You are asked to find, having given these sections and all, have we already done. If I cut here, okay, if I cut here, the cut section at this point, say XX, will give you the dimensions like this. Section at XX will be a rectangular one, right? A rectangular one. The member cross section is rectangular with a 40 mm depth and then 10 mm thickness, perpendicular to the file. Okay, perpendicular to the sheet here. You can see 10 mm, 40 mm. You can see very well, right? So, what else given to you? Rectangular cross section at this point, and then ultimate strength are given. What is ultimate strength? Quickly, Kankanala, one by one, quickly answer me. What is ultimate strength? Due to the material, right? It is the ultimate strength here is referring to ultimate strength is referring to strength or stress. Both units are same. or stress is referring to the material property. Okay, material property, how much it can bear the load. What is the allowable? What is the maximum strength that it can bear? If you see the stress strain graph, ultimate strength is the strength at which until then you can load, after which it will start breaking. At one point it will get broken. So this is the ultimate strength of the members are given. This is steel. Okay, this is also steel. The pins also steel pins, and this ultimate strength are given. The strength in tension is given for the member 400, and the strength for the pin also given in shear strength for the pin also given, because the pin is undergoing a shear stress. So the value of the bearing or allowable is also given as 150 megapascal for the pins. Okay, you are given these values and asked to calculate what would be the factor of safety with this condition of loading. They are supposed to load this much with this strength. Okay, with this strength, what would be the factor of safety to have a successful design, no failure, no breakage, right? Given data quickly, before solution you need to write the given data. Given data are, you are given with number one, the strength, ultimate strength, right? Ultimate strength is ultimate strength or stress. You can have it as ultimate strength or stress. I keep it as it is in stress, right? Ultimate for the pin, right? Pin and the link. Okay, link and the pins are given to you. Let it be L, link. Or I write link. Ultimate strength of the link is given as 400 megapascals. And then ultimate strength of the pin, ultimate strength of the pins are given as pins are given as 150 megapascals. Always read the data twice. Your questions, your answer starts from there. You can directly take the answer from there, right? It is like mathematics. Mathematics also, you read the question, the answer is there in the question itself. So you are given with stress itself means half of the question and answer is given to you already, right? Stress is given, and then you need to know how much you can apply. All of you know you are asked to find factor of safety, right? Check whether you have all the formula and the required data for you to solve. Solution, that's all right. The section written already. Number one is a section, right? Number one is section. Number two are the strength is given to you, and then anything else? Diameter of the pins are given. Okay, diameter of the pins are given. Pin, I put the diameter as a 5. 5 referring to the diameter of the diameter. Pin is 20 mm. Remember, okay, the pin circle 20 mm diameter. Okay, and then this is pin. This is pin. This is link. What else? Connecting horizontal members. Okay, these are the conditions given to you. You need to solve for factor of safety for these two, right? Okay. Required answer will be, you also can write the required answer so that you can have a solution done properly. Required answer or the solution will be, you need to find factor of safety for the pins, factor of safety for the links. Okay, how much this and this, okay, put together in this frame, how much is the value for links and the pins. Okay, what else? Should be clearly written. How do you define factor of safety? We go from the question. Determine the factor of safety. What is the factor of safety formula? Solution. Solution started here. Factor of safety is defined as factor of safety is defined as It's not detecting me. It's in touch mode, right? Okay. How do you define factor of safety? Anyone? How do you define factor of safety? Is equal to ultimate. Ultimate is the material property, and that should be very high. That's why you put it at the top. Ultimate strength or stress or load. Ultimate stress, you check whether I'm doing correctly or not. Allowable or applied. I can say applied. Ultimate to apply, let it be applied, then easy for you to understand. It is going to, you are going to work on this design. Ultimate to applied or allowable. Okay. Ultimate stress to applied stress. Apply means it is going to come over the future loading. Better keep it like this. Otherwise you cannot differentiate. Allowable means a bit confusing. Right. This is the definition. So you are given with this answer. You don't know this, right? What is the stress acting on this member? Because you are only given load. Stress need to be calculated. Stress is load per unit area. So take the point of interest, calculate the stress, so that you can calculate the factor of safety, right? You don't know this, you don't know this, but this can be found by given data to do, right? Let's draw the line sketch so that is easy for us. Our point of interest is at the pins and the CF and the pins, okay, at this point. So just draw that line diagram only, line sketch or free body diagram, so that you know where what are the loads, what are the reactions. Free body diagram. What do? You can take this member because you are finding for the load is applied here, and for this link, okay, you can translate C to F. When you do that, it will be like this: member E, F, and then G. Keep the same name. E, F at 0.4, G at 0.25. F at 0.4, G at 0.25. Okay, G at 0.25. 0.25. All meters, am I correct? Oh, meters. I changed to meters only. Right? These points we have done. Again, pin. Remember, this is pin. Don't forget. And then C can be translated to F, B to E, and then loading G. Loading is G. I do it in a different color. It is applied with the loading 20 kilonewton at this point, 24 kilonewton at this point G. Okay, G is subjected to 24 kilonewton. Okay, what else you have? Right. Anything else to mark? When this is subjected to loading and there are pins, right? Here also pins. Pin. It is a pin. It is a pin at this point. It is a pin at this point. It is a pin at this point, right? When it is subjected to loading, automatically there will be a reaction at the pins, isn't it? Vertical reaction at the pins. What will be the direction of reaction at this point? It will be vertically upward. It will be vertically upward like this. Reaction will be developed due to the loading. Reaction will be developed at F. And then E is also, but let's see how we are going to do it. And then what else you have to mark? That's all, right? We don't know what is the type of reaction here at E, because see, technically speaking, when you pull this point by a loading, when you pull at G with the loading, it will react in opposite direction to withstand or restrain the loading, resist the loading. At this point, due to pin at this side, on both sides, right? It is pin this point, at this point it is pin here and also here. Due to this, it may be upward or downward, we do not know. But you can assume initially and then solve, you will get the right answer. Okay, let it be like this. And then let's find out the reaction, right? We need to find out the reaction because we don't have the, we just have the loading. We want to find out the stress at this point. Stress at this point. Hence, I need to know the loading at this point. Am I right? I don't know the loading. If I only know the loading, how much it is reacting, and then I can calculate the distribution of the stress at F so that I can find the factor of safety at F. These are the unknowns here. Okay. Okay. He's jumping here and there. Right? We are here. How do you find the force? We can resolve the force above E, right? This is the pin. To find the unknown, either you take G or E, but I want to know how much is the reaction at this point. So I need to make use of the loading. Let's take the point E. Okay, resolve the moment about this point section E. So when you resolve the moment about E by equilibrium conditions, all the moment at ME should be equal to 0 because of pin joint. Taking this criteria, let's resolve all the moments about E. Start from G, 24, right? 24 is how much? Positive or negative? 24 kilonewton, positive or negative? We'll change to Newton. Positive, right? It is rotating this way. Keep the clock means it is rotating this way. Many times I don't done this. So positive, and then going to F into what is the distance? Moment. We are taking moment, right? What will be the distance? This is the force times moment will be 0.65 from here to here, right? From this point to this. From this point to this. We are resolving about E. So we will have into 0.65 meters, and then I've done for G, then F. F will be positive or negative? Negative. That is our unknown, right? So it will be force, reactive force, let it be FCF. For CF I am taking FCF, the reaction be FCF times how much is the value? Into 0.4, simple 0.4. Clear? We have done for this unknown equal to 0. How much is the FCF value? I want somebody to answer. Ongzian is there? Please answer me, how much is CF? Ongzian. How much is the value of CF in newtons? Get me in newtons. And move on. Quick. You have all this thing done? Ongzian? How much? Quickly. 39. Exactly 39 into 10 power 3, correct? Because newtons. 39 into 10 power 3 or kilonewton, you can say kilonewton. But we converted already into newtons, right? So it should be 39 into 10 power 3 newtons, right? Moving on, we found the load. Now we can find the stress distribution or strength. How much is the strength value? Either you can calculate by the strength or by loading, right? Newton done. Based on tension links. Based on tension links. Next is the we are going to find. We just found the unknown. How much the load at this point? Now we can conveniently find the factor of safety because we got the loading, we got the strength. With this applied force, with the allowable strength, we can find it. But allowable, you need to what do you call here? Where is it? Nee, this one. This is our ultimate, right? Ultimate strength is given, but you have to find out the ultimate load, right? Because we want to compare between ultimate load to ultimate allowable load. Okay, let's find out. Are you here? Clear? One answer is found out. This is our ultimate. The stress and the loading. Oh, sorry. Okay. One answer we have got already. We are going to find the factor of safety. Well, let me write down the where is the factor of safety definition? Is here. Factor of safety is ultimate stress by ultimate applied load. Okay. Further, you can divide into either you can compare by stress or load. It is ultimate load, ultimate load or ultimate force divided by applied force, applied force or load. Both you can define it. You can also define by load, given load. So we found the load at point F, that is our point of interest. We need to find factor of safety and the at these pins and the links at F. I found the load. Let's find out this is the applied load. This is the applied load. Now let's find the ultimate load at this point. How much is the ultimate load at this point? At this point at F, okay, at F you have two things. One is the link, one link which is CF, correct? CF and the pin you need to find separately for the link and pin. Okay, for the link let's do one by one. For the link we find separately the factor of safety. Okay, for the link you can calculate the factor of safety like this. I repeat the sentence. Factor of safety for the link is equal to ultimate load to elbow AD to applied load or allowable load. Okay, applied load or allowable load. Okay, we know this applied load just now we found out at this point. We found out the applied load at this point. Okay, we know applied load is equal to just now we found at F is equal to 39 into 10 power 9 newtons. Now to find out ultimate load is equal to you are given with ultimate stress, right? Ultimate stress into, I have to have some space because stress is equal to force over unit area, isn't it? Force over unit area. Now you are given with stress, you can find the force. Load is equal to stress into area, right? Load is equal to stress into area. That is what I'm doing here. So ultimate stress times area at link, area of the link. We are doing first for the link. Okay. Let's find out the load. You are given with ultimate stress. How much is that? Later we substitute. Let me find area of the link. Do you have area of the link? Don't have, right? You need to find the area of the link first. Correct? How much is the area of the link? Let's find out area of the link. In this unknown is area of the link. Take the cross section. Just now we draw, right? The vertical cross section. I draw the vertical cross section. It is 40. The thickness is 10, right? I draw the bigger one so that you are clear with. You need to find the contribution of the link. How much is the link area supporting this loading? If you take the link, it is like this. Okay, this is 40. This is 40. Okay, 40. Perpendicular, this one is 10. Don't worry. And then inside got a pin, right? How much is pin dimension? 20, right? So I need, so on the area that is contributing to this, the area of the link that is contributing to this will be this much, isn't it? This is the value of the area that is contributing to the loading. So I have to deduct this value. Area is equal to area of the link. Area of the link is equal to B minus D. B minus D into T. B is where B is the 40 or D. Let it be this one. This is for the link. This is for the pin. Okay. I put it as D itself, easy for you. Depth of the link to depth of the pin. Depth of the link is given by 40, which is 0.4 minus 0.04, it was mm, 0.04. And then for others, how much is the value? Depth of the pin 20, also 0.02. Clear? We have done this part. And then times thickness. Thickness of the, you see here in this view, you can see clearly the cross section already drawn here. The thickness is 10 mm, isn't it? Thickness means this portion. The thickness of this one is 10 mm. 10 mm. So here if you want to see this thickness times the depth, okay? This thickness times the depth is important. This much depth of the link is contributing to this load and the stress distribution. Hence, you need to calculate the net value that is also contributing to this stress distribution by deducting the pin. That is what I drawn the cross section here. It will be times 10 thickness of the link. This is the area contributing to this stress distribution. How much is the answer, please? Give me the answer. What is the answer? Derek, what is the answer? How many of you joined class? Only 11. What happened to 2 more? Derek, are you there? Yeah, he's there. Ahmad Hassan? If not Derek, Ahmad Hassan, are you there?
Yes, miss.
Yes, miss. Can you give me the answer for this? Area of the link?
What?
Area of
Okay.
the link. Answer
Yes.
for this. Others, mute your mic, please. How much the area of the link?
Is it 200 millimeter square?
Yeah, correct. 200, very good. 200 into 10 power minus 6 meter square. Let it be meter square for now. And then millimeter also you can keep it. I keep it as meter square because I'm going to substitute in meters later. Right,
Miss,
we got the area.
2 times 10 power negative 4.
Negative 4, miss, not negative
Yes.
6.
2 times 10 power negative 4.
Why negative 4? I'm writing in meters. 1000, correct? 1000.
Ah,
1000. Okay. mm 2 meter. Okay. Next is the, what do you call, your value of, we got the answer for area. Now we can conveniently substitute in this formula to get your answer for the factor of safety, isn't it? Right. Now, do you have this value? You don't have this value, right? You need to find this. Okay. Ultimate stress is equal to, I keep it as 1. Substitute in 1. Just continue with this. Okay. Our ultimate load, ultimate load FU, let it be FU. FU, right here itself. Ultimate load FU is given by, what is the stress value? Ultimate stress given to you is what? How much? The member can bear up to. Ultimate stress, the link is 400 megapascal. The stress value is 400 megapascals. Ultimate stress that it can bear. Let's convert into pascals. This is pascal times the loading, right? The area times loading. Correct. Times the loading. Okay. Times the area. How much the area we found out? 200 into 10 power minus 6. And this due to the, because we are asked to find out the for the whole system, right? For the whole system, how is the overall factor of safety? For the whole system, how is this? Because the response here is due to response of this and this link, right? But you are asked to calculate at this point. Hence, you need to multiply by 2. 2 links are acting at this point. Hence, you need to multiply by 2. Is the response or reaction due to the 2 links? Because of the 2 links are double links, you have to find multiply by 2. What is the answer here?
80,000 Newton.
Why 8,000? Wrong answer. Please check. Did I substitute all? Area is there. Load is there. I mean, load we find. Stress is there. How much is the value? Quickly. I have to close your class shortly.
160 into 10 to the power 3.
Who is this girl? Nice voice. Who is this?
Harshita.
Harshita. Long time back. Okay. How much is the value? 160. Very good
Into
answer.
10 to the power 3.
10 power 3. Because I always hear male voice. All should be active in the class. Okay, good. Let's move on. Now we found out the ultimate load for this one. Can you find the factor of safety now? We have the load, ultimate load, applied load. Okay, 2 gentlemen are here already. Can we find factor of safety? Factor of safety. Safety, mind the spelling. Safety at the link. At the link is equal to formula ultimate load, because you all have load only, right? Ultimate, why am I highlighting that? Right, just a few, I do a few. Ultimate load to applied load. Okay, I treat this as AFP, applied load. Applied load, FP, okay? Applied load, FA, FA, for convenient way. Okay, allowable or applied. Shall we do now? Ultimate is 160, right? 160 times 10 power, but it is over designed, but better. 160 times 10 power 3 divided by applied load is 39 times 10 power 3. Come on, get me the answer quickly. You got your factor of safety. Factor of safety for your links. So one answer done. 2 point?
4.10.
4 point, very high, 4 times, 4.1 is your answer, is the number. One answer done already, we got one answer. 4 times, what do you understand by this? Your actual is capable of bearing 4 times that applied. Only 39 is applied. Your member can bear up to 160. 4 times bigger you are designing, over design, okay? Then you can adjust accordingly to remove the link and find out, put an sufficient amount according to the load. You can remove the link or relax the pin and so on. You can do it, right? Next category is for, this is for the link, right? Next is for the pin. Same you have to repeat for the pin. For the pin, factor of safety for the pin, all the calculation analysis for the pin. Okay, can you repeat the same thing? Number 1, you got the load, right? Both applied load will be the same, right? Applied load we already have. We only need the allowable, or we have to extract the value from the ultimate stress to find your value for factor of safety. Let's start with calculating the same formula you use. Ultimate strength is given to you, the same repeat. Ultimate load is equal to ultimate load at pin. This is for the pin. Ultimate load Fu at the pin is equal to ultimate stress times ultimate stress times what? Area. Can you substitute and find out? Ultimate stress times area at the pin, area at the pin, or contributing area at the pin. Okay. Do we have the area? We need to find out the area. Area of the pin. Area of the pin is fully undergoing, right? Area of the pin is not hollow, it's a solid pin. So you just find the area of the pin. area of the pin as pi d square by 4, isn't it? Pi d square by 4. Pi d square by 4. Area of the pin. So whole pin is in action for reacting to the load applied 24 kilonewtons. Pi d square. How much is d? Diameter is 20 mm. Square divided by 4. What is answer? What is answer? Area of the pin is equal to anybody? Area of the pin?
5 into 10 to
3.14
the power minus
Okay, 3.314 and 314
times 10 to the power of -4.
-4. No. Anybody? Wrong answer. Negative.
6.
Be more careful. I will ask you to enter the answer only. In that case, if you give wrong answer, I'm sorry. The whole mark, you lost your mark already. Okay. Be careful. Work out and check, and then submit the answer. Right. The pin area is found. Let's use the formula to find. Substitute in this formula. Right. Substitute. We got the area. We got the stress. We can find the load. Right. Okay. Ultimate stress, how much is the ultimate stress? Fu is equal to, in this pin, ultimate stress is, how much is ultimate stress given for the pin in the question? Ultimate stress is already given in the question, right? Ultimate stress for the pin is 150 megapascals. 150 megapascals times area, right? Area is how much? This one, A pin, or I substitute the value itself. Convert the value of megapascal, everything you convert it into 10 power 6 pascals, Newton per meter square, you got it, into the value of what is it? Area 3.314 into 10 power. You put the points, everything. Okay, put the points. 3.314.16, correct? 16 into 10 power minus 6. Same goes to pins. There are 2 pins at this point, right? So you have to multiply by 2. Multiply by 2. Okay. Answer. Give me the answer for the pin. Ultimate loading at the pin. Quickly.
212.
9424.
Very good. 94. 94.24. Just leave it like that. 245 also. 25 also okay. Correct to this one. 25 also okay. Okay. Good. Into 10 power. Anything is there? Yeah. 10 power 3 newtons or kilonewtons. You can put it. Either kilonewton or newtons. 3 because the other one is in newtons, so let it be in newtons. Into 10 power 3, and this is 10 power 3. Why my hand is like this? Okay, done. Now we got ultimate load and applied load. This gentleman is applied load. 13 is already your applied load. Same goes to pins. Let's find out the factor of safety at the factor of safety. Factor of safety. Factor of safety at pins. Pins is equal to ultimate load at the pins over allowable or applied. Let it be applied. A small a. Okay, what is this value? Ultimate is how much? Load just now we found 94.25 into 10 power 3. And your applied is 39 point 39 10 power 3. What is the factor of safety? What is the factor of safety?
2.4166.
2.4.
1.
Oh, 1 or correct to 2. Okay, both are same, correct. But always in the calculations we will give some range. Okay, don't worry. This is the factor of safety at the pin. Okay, so we found both answers. This is your second answer. Both answers are done. One answer is factor of safety at the links is 4.1. Factor of safety at the pins is 2.42. Any question we have done for this question? We are moving on to next one. Any question in this solution? So like this type of questions may come, we must be careful in analyzing what is given, what is the formula governing, what is the principle using, what is the point of interest, right? All these things are matter to analyze the member. Let's move to the second one, very interesting one. I request for this very simple question, such a simple question this one. It looks very big. Such a simple question you may have to follow carefully to understand, right? Just 2-line answer for this one. You don't have to worry about. Okay, let's solve this one. Are you ready? Okay. Right? The force applied at handle of the rigid lever causes the lever to rotate clockwise. About a pin B. Where's the pin hand? The pin B. There's a pin, that's why about a pin B. From here, to start from here is the pin. From about B, it is rotated at an angle 2 degree, 2 degree, making an angle 2 degree. Determine the average normal strain. Now we are going to do the strain. Last time is all about stress and factor of safety. Now is the second factor that we learn, strain. How much the strain in each wire? The wires are unstretched when the lever is in horizontal position. Do you understand the question? You are given with this is the support, right? There is a wire and this is pin and there is a support, wire is hanging, and this is your another support at F, a wire is hanging, and there is a handle. Okay, all these things are at equilibrium condition when no load is applied at E, and as it is stable with the depth at AH as 200, depth at GC as 200, depth at FD as 300. No, I'm sorry. GC and FD are 300 at equilibrium condition or no load is applied at E. When no load is applied at E, it maintains 300 and 300. This is the wire's length. They are flexible wires, okay, steel wires. When a load is applied at E, it will tend to stretch itself, elongate, okay, change in length. The position here can move to this point. The position here can move to this point, It is a little bit lower down. So how much is the value we are going to find now? You are asked to find, you are given with these conditions, you are asked to find the strain values at each wire. What is the strain value? What is the change in length? What is the change in strain? Not change in length, not just change in length. What is the strain at this point? So there's delta. If I keep the value, because I want to use the same notation that I use in the class, it is the AH, right? Delta AH, small one. I use a small one, easy for me to write. Delta AH. This is delta GC. This is delta FD, right? So these are the change in length. Okay, let's find out one by one how this is going to vary and how we are going to analyze this member. Any question here? Right. Whether I can remove this part, okay. Given data, write down the given data. Given data. Please work along with me. Are you doing it? All are doing it. Given data, you are given with the members and the depth, original depths are given. Better you write down the original depths, otherwise you'll get confused. Given that, sorry, I had the charger finish. Okay, one moment, I will call you just. Let's drop down only. Okay, done. Write down the original length, that is important. You are asked to find strain means find out the original length first and the point of interest. You are given with this frame, you need to calculate the strains at each wire. The wires are AH, GC and FD. What is the original length of AH and all? L, let it be, if I take the original length as capital L, LAH will be 200. Be my handwriting like this. 200. What is the unit? Mm. Let it be mm. Okay, all mm. Because I'm going to find all in mm. Convenient way. And then what is the length? I write here to save some space. Original length of GC before apply load. Before turning in, original length at GC will be how much is it? Anybody? Original length of GC will be given data
300.
300. Original length of FD will be 300 also. Okay, you can even put equal to 300 mm, same. Okay, that we must know. And what causes? There is an angle. There is no delta given, but angle is given. Now a simple conversion of angle will can give you all the change in value, change in depth conveniently. Right. Let's convert this angle into radians. Or before we do this one, let us draw the diagram first. Okay, diagram how this is changed. I do it here itself so that it is clear on this diagram itself. Okay, delete this spot. The angle of deflection will be something like this. About the member, when there is a rotation like this, when there is a rotation, when it is rotated in a clockwise direction, automatically the member will change. AE will change to AE dash or AD dash, AD dash, A dash D dash. The line will be, let me insert the line. The line will be like this. About, it's going to rotate about. It's better I get the line. Oh, got it. It will be like this. It will change to. It will be like this. Okay, and the line will tend to rotate like this. Okay, it will rotate above B. Now let's mark the values. A change to A dash position, B is there. C change to C dash. Where is it? C change to C dash, and then D change to D dash. D change to D dash. Okay, put the dotted lines in. Because of this rotation, the position of the wire, position of the member. If I take this as a, what is written as a handle applied to handle, force applied to the handle of rigid lever. This is a lever. This is a lever. It's a lever arm. And this is the lever. This is the lever or lever. You can use anywhere. Lever. This is the lever arm. This is the arm. Lever arm where you tend to rotate lever arm. Okay. Lever arm. Okay. Now when you rotate it, the lever will change the position from AD to AD dash and E dash. Okay. We are rotating actually. Let it be like this. So change to AD dash actually. You see the differences in the values. What is the angle of rotation given? It is about B. How much is the rotation? How much is the rotation about B? 2 degree, isn't it? Since degree is given, you need to convert to equivalent values. You must know the equivalence of the radians between the degrees and radians. If you convert, you can conveniently calculate it. Okay, 2 degree. The angle of rotation is given. I am marking this one, and then we can solve for the answer. Okay. Okay. Let's take the diagram separately so that it is clear for you. Actually, these values are not useful to you. Okay. For a moment, you have to forget it. Otherwise, you confuse between these. We are not doing any horizontal things. Better you forget for a while. We are only finding the strain. Strain means elongation, and the strain at AF, GF, and FD are important. In doing so, you need to find the original and change in length in the members given to this. Okay, right. Let's start from this one. Okay. One moment, there's a message. Right. Now, what is the value? We are going to find the change in value at these points. How much is the relation? What is the relation between, what's the required answer? I just write the required answer. Required answers, strain value. I mark the strain at this point. Strain at AH, strain at CG, and strain at DF. DF. Okay, these are the values asked. Let's calculate one by one. Okay, start from here. Solution. You must know the variation between, and this is the one of the solution is the free body diagram. I have drawn in the diagram itself. Please make use of it. And then our original length is AD, change in length is A dash D dash, the change in position. This is the original position, this is changed position. Okay, right. And then you should know the difference between, one moment. You should know the difference between the, the relation between radians and, what is the relation between radians and degree? I think you should be knowing. What is the difference between radians and degree? Any idea? Radians and degree in trigonometry you would have studied. If not, write it like this. We know that pi radians equal to 180 degree. Okay, pi radians equal to 180 degree. Because we cannot substitute 2 degree as it is for calculating the values. It is possible by trigonometry, but let's change to radians. You are given with 2 degree, right? So I want to calculate changing 2 degrees into equivalent radians. How do you do it? You use this one. So pi radians equal to 180 degree. How much will be the 2 degree? What is the answer here? You will get in radians. How much is the radians? Give me the answer, please.
0.02491.
Very good. 0.035 or 39. You keep it like this. Radians. This is the value, equivalent value. So I got the value in radians. How much is change in value at this point? Right. Now let's use the formula at each and every point. Solution. The strain at, what you're asked to find out? Strain value, correctly. Strain value at, or I just use the formula itself, epsilon. Let's write the formula. Epsilon, what value you need? AH, G, CG and DF. AH is equal to epsilon. Epsilon I sigma I put. The strain at AH, I'm not getting. Strain, what happened to me? One moment. Okay, same way I can write. Strain at AH is equal to change in length at AH, isn't it? Change in length at AH divided by original length. I don't write for everything. You have to remember, okay? Original length at AH. Okay? Original length at AH. So you repeat the formula everywhere for all the 3 points so that you can get it. Length at AH. Okay? What is the change in length? We need to find out delta A, right? Let it be delta AH divided by LAH. Do you have delta AH? Don't have, right? You need to find delta AH. Delta AH is equal to, what is the value of this one? The radians we found out just now 0.349. Am I right? Okay, come on, mark here. Okay, we want the value at this point. This is the dotted line, dotted line. Dotted line. I put it at dotted line. Okay, originally it was at this point, changed to this point by this degree, right? And the original was 200, changing was this one. Can we rearrange and get it? Can we rearrange and get it? This is sigma, right? Sigma. Delta, okay, difference in height. Can we now rearrange and get it for delta value? Shall I write the value here? Delta AH is equal to 200 times 0.0349. Just leave it like this. Enough. What is the answer here? What's the answer here? You want the change in length, right? Then we need the delta for equivalent delta AH. For getting equivalent delta AH, I put this 200 times 0.039. How much is it? This is original, right? How much is the value? How much is the answer here? Delta AH. We are only finding delta AH, okay? Change in length.
6.98.
Correct. And then 98 mm. Are you clear? Any question so far? Am I rushing? No. Okay. And then this one. What is this value? Delta C. What is the value? CG, correct? Original is 300 and delta CG. Original is how much is this? 300, right? 300 times 1 moment. Oh, we need to find the based on this one. Better I write the equations. Otherwise, you will not follow what you are writing. Better I do with the diagram. Okay, easy for you to understand. One moment, I will explain here itself. Okay, now you are given with the angle, right? Opposite should be, this should be also be 2 degree, according to trigonometry. This should also be 2 degree, right? To find the unknown here, a to a dash, you can follow the trigonometry. You also have the conversion factor, no problem. Either you can take the tan theta, right? Tan theta. If you take the tan theta, it will be the value of opposite side by adjacent side, right? If you want this value, it will be opposite side by adjacent side, right? AA over 200, right? If you want delta A, AA, it will be 200 times the change in length. And then similarly, if you go here, GC, right? GC value, follow this triangle, the known value. 300 is the known value, right? Already there. So for opposite side, you want this one, right? Delta C dash. This is delta A dash here. Hello? Hello? Oh, sorry, one moment. Hello? Level 3, yes. Level 2. Yeah, level 2. Level 2. Okay. Level 2. Okay. Okay, thank you. Right? I want to finish it. right? Or what happened? Okay. And this case, in the diagram, consider B, C, C dash. Okay, opposite side by adjacent side will be C, C dash by 300. And then for DF, consider this triangle, B, D, D dash. When you consider B, D, D dash, you will get what is called delta D, D dash. Okay, B, D, D dash. It will be opposite side. You want opposite side will be adjacent side. Tan theta equal to opposite side by adjacent side will be the whole length 500. Okay, whole length 500. Okay, like that we are calculating these unknowns by following these knowns, right? Okay. In doing this, we do not remove this one. Let's find one by one this value. How much is this value? If I find one by one, it will be clear. AH is equal to delta AH over original length AH. Okay, I need delta AH, which will be equal to, consider the triangle. If you want, I draw here. Consider the triangle like this. I consider the triangle, dotted line, then this one. This is my B, right? About B we are finding, about B. There are many ways we can find, but this is one of the way, right? This is delta A dash, isn't it? Because this point is A, this is A dash, and this is degree is 2 degree. To find what is this value, I take tan theta, because theta is already available for me. Okay, tan theta. Why I don't consider tan? Because for my smaller angle, you can smaller and very low slopes, you can just take it as theta itself. Okay, I repeat, tan theta is equal to opposite side by adjacent side. But for smaller angles, you can take it to be theta itself. My opposite side is delta A dash divided by adjacent side is, how much is this? Please find. 200 mm, correct? Please tell me the answers. 200. Hence, I will take my delta A dash. Delta A dash. One moment. Okay, delta A dash will be equal to, or I write here it's better I follow here. Delta A dash equal to theta times 200 mm. My theta in radians is equal to theta in radians. Radians is equal to, you know value, right? Can you substitute and give me the answer, please, quickly? 0.034. You're going to find out the remaining, please. 349 times 200. What is the answer?
6.98.
6.98 mm. Okay, you can keep 3 digits. Okay, you always keep 3 digits. 981 mm. Okay, this is the value of delta A dash. Okay, let's substitute in this equation. I found the strain already. How much is the change in length? Let's find out. Substitute in this case. My value of, after this, maybe I go here. The strain at, just repeat the equation. Strain at AH will be equal to change in length. We'll keep changing. One moment. Okay. Repeat the same thing for all the positions. Don't forget. Hold on. Just. Can you repeat for other sections? Now I do it for here. Delta AH, change in length to the original length, which is change in length just now we found out 6.98 1 3 1 or 1 3 you can keep it, and then what is the answer for origin length? Origin length at A will be LAH will be how much is that? 200, right? 200. Yeah. 200. Give me the answer, please. This is the number one answer. Can you similarly find out the for the remaining? Just follow the triangle. You can conveniently substitute the values. What is the answer? Hassan, last time also you didn't answer.
0.034.
0.0349 mm per mm. Okay, this is strain, right? So the unit will be mm over mm. Just write it like this. Change in length to the original length, all in linear meter. Let's find out the second value. We need to find strain value at CG. Okay, strain value at CG. To find this, same, follow the formula. You know that the strain is equal to change in length to original length. Am I correct? We need to find the change in length by using the trigonometry given to you, the geometry given to you. Change in length at CG is equal divided by original length at CG. Change in length is denoted by delta CG divided by origin length CG. You need to find out what is this. Origin length is, how much is origin length? The length of the wire. How much is the origin length? Better I substitute and keep it here. How much is CG? Are you there? Okay, 300 mm. Okay, let's take the dimensions there. Your dimensions are like this. Let me draw here. You have CG, right? CG is from B. Take this as a B, and this is the lever, and this is the change in length, right? Change in length. You have C dash, okay, C dash, and the angle of this one is 2 degree, right? Width is 300. Let's find out theta. Same as the last time. We take tan theta, or just the theta is equal to opposite side by adjacent side. C dash by adjacent side is 300 mm. C dash is how much? We need to find, but we know theta, right? We can substitute for theta. 300. Better I substitute the value here. 300 is equal to how much is the theta in radians? How much is the theta in radians? Just now you found out. Give me the answer, please. Otherwise, it's boring. If I'm only doing, it's boring to you. How much is theta value? 3 point. Give me the theta value. Radians, in radians. 0.03491 is equal to CC dash by 300. Let me find the CC dash. CC dash is equal to 300 into 0.0349. Come on, give me the answer, please.
10.47.
10.47. Very good. Next, please. 10.47 mm. What will be? This is the CC dash, the change in length, right? Change in length, or delta. Say delta. What I wrote the notation. Use the same notation. Delta CG. Okay. Now delta CG is equal to. This is the value. Let's find out the remaining. Delta CG. Can you find the strain? Strain is equal to delta CG divided by original CG. Substitute the value delta CG divided by original. What is the original CG? 300. Can you find the answer? 0.0349. Also the same. A little bit variation only. Okay, first and second, because they are near to the support. Both are equidistant from the support, isn't it? That's why you're getting same. Both the point C and E are at most equidistant from the support. A little bit variation only. That's why you're getting similar value. You should be able to justify your answer. Right. let's go on to the next one. I have to arrange for the next test. I'm so sorry. Can you finish the last one? I draw the diagram only for the third one. I have to go now. To find your strainer. What is the notation there? Let me do strainer DF, right? FD. FD. I use the FD, right? I use FD. Yeah, FD. What is a strainer? FD. FD. I give the drawing only, please do it, okay? This is B. If you consider this as B, and you have C here at 200, at 300, sorry, at 300, C at 300, C at 300, and then C at 300, and then another one is at D. Please. Another value is at D. D is at 200, okay? So the change in direction will be in this way. We are going to find out the change in value at DF. I mark this as DF. Okay, DD dash. DD dash is equal to DF. This is the value of C. So totally you have 500, right? And the angle of change will be 2 degree. Can you repeat the same answer for the third case? I did 2 cases already. Can you repeat it for the last case? I give you the answer. The answer is strain at DF is equal to 0.6. Use the same procedure. I'm not giving different one. You can follow the same procedure to answer for value at this point. 82. The answer is 82. Mm over mm also. Okay. 82. Okay, I stop here. Any question you can ask me. I end the class now because I have test after this, and see you next class. If you have any question, you can text or message me, okay, in the WhatsApp or MS thing, okay. Let's save this file. I'll post this file later. All of you must complete the third case, all right? Okay. Any question? Quick question?
Miss, how many question is in the test?
The pattern shall I write to you? Maybe because you are writing for 1.5 hours, right? I will give 3 questions. 3 questions to answer. Minimum 3 questions like the one we solved today. You may take 20 minutes each, and then for submitting another 10 minutes. Okay?
Okay, thank you, Miss.
I will write the description, how the format of the test and the timing. We'll have to prepare on 3 chapters, 2 CLOs. Bear in mind. If there is, you can follow the notes at the YouTube there, and also your slides posted on CN. All right? Okay, bye-bye.
Thank you.
You're welcome.